Hey there, y'all. Today we're going to look at 2.6 on solving inequalities with variables on both sides. And so our objective today is that you will be able to solve inequalities with variables on both sides and be able to identify cases that have no solution or infinitely many solutions. We continue this in the standard of AREI 3, being able to solve linear equations and inequalities in one variable, and including equations with coefficients represented by letters. And so here's the biggest thing to remember, and we talked about this in section 2.5. Remember that this is the same process as solving equations. So remember, if you can solve an equation, you can solve an inequality. And so remember to simplify each side first, and then start moving things around to get that variable by itself. And so we're going to start with some two-step inequalities here. And so when we look at this first problem, 4x plus 7 is greater than 19. And so when we look at this problem, remember that we want to get this variable by itself. So this x, and think about what's attached. We have the 4 is attached to the x. Remember, when a number is attached to a variable with no sign, it's multiplication. And then we have that plus 7, so that's by addition. And remember that we are undoing everything using our order of operations to undo it. And so our first step is to subtract 7 from both sides. This will cancel. We get 4x. The inequality symbol comes down. Make sure you keep the inequality symbol. And remember how we talked about in section 5, the only reason you flip it is if you multiply or divide both sides by a negative. 19 minus 7 is 12. And so our second step, divide both sides by the 4. And so x is greater than 3. It also told us to graph it, so we need to make sure we take our number line. Here's 3. To the left of that is 2. To the right is 4. Is 2 greater than 3, or is 4 greater than 3? 4 is greater than 3, right? And so at 3 we have a circle because it's not equal to, and it is shaded towards 4 because 4 is greater than 3. And so that's what our number line would look like. And so all these problems that we're going to look at, the steps are the same. We're going to do a few more, but remember, it's all about getting that variable by itself, understanding what symbol I'm going to put at that critical value. Remember that what we're relating to is the critical value in the end, and then which way does it shade? And plug in those values to see which statement is true. Don't think about left and right. I told y'all, don't think about left and right. Think about the values that plug in to make this statement true. So let's look at example 2. So in example 2 here, we have x plus 7 all over 3 is less than or equal to 5. And so remember, we're still going to think about our order of operations. But when we have a fraction like this, we have to think about this entire numerator being in a parenthesis. And so to undo that, I'm going to multiply both sides by the denominator. And so in that case, I'm multiplying both sides by 3. Now, this 3 cancels this 3, so don't distribute that into the x plus 7. The whole purpose of multiplying by 3 is to cancel that denominator. X plus 7, less than or equal to 3 times 5, 15. Okay? So now we're down to one step. And all we have to do is what? Subtract by 7. And so minus 7 and minus 7. And we get that x is less than or equal to 8. And so drawing our number line, here's 8. To the left is 7. To the right is 9. What are we going to put at 8? We got that equal to bar in this case, right? So we're going to put a what? A dot. And which way do we shade? Are we going to say that 7 is less than or equal to 8? Or is 9 less than or equal to 8? Which one's true? It's the 7. And so we're going to shade towards that 7 in the end. Okay? So again, pay attention to the steps. Pay attention to getting that variable by itself. That's the key to these problems. Let's go look at example 3. So in example 3, we're given negative 5x minus 7 is less than 43. So we're going to start with our first step here. We're going to add 7 to both sides. That will cancel. Negative 5x less than 50. Our second step. We've got a negative 5 times the x, so we're going to undo that with division. So we're going to divide both sides by a negative. But this is where those red flags should be going off. What did we just do? We divided by what? A negative to both sides. So what has to happen? we have to change this inequality, right? And so what we're going to get, this will cancel, x, switching this inequality is now greater than, and what's 50 divided by negative 5? Negative 10. And so we're going to put this on the number line. Remember, we're dealing with the negatives here, so to the left of negative 10 is negative 11. Remember, we're in the negatives, so as we go further to the left, the number itself gets bigger, right? Not that the value gets bigger, it's just the numbers are bigger when we think about like the whole numbers. And so negative 9 is to the right. And so at negative 10, we're going to put what in this case? It's greater than, so we're going to put a circle because it's not equal to. And then the statement, is negative 11 greater than negative 10, or is negative 9 greater than negative 10? And remember, when you're dealing with the negatives, your intuition's backwards, right? So the smaller the number is, the closer the number gets to 0, the bigger the number is, right? Because we're heading further to the right on the number line. And so negative 9 is greater than negative 10. And so my shading will reflect that, shading towards negative 9. Okay? So make sure you draw your number line right, make sure you get your numbers in the right spots, and then understand which statement is going to be the final one. Let's look at example 4. So in this final problem, we have 4x minus 5 is greater than or equal to 20. So in our first step, we're going to add 5 to both sides. And so 4x is greater than or equal to 25. Our second step, we're going to divide both sides by 4. And I know what some of you are about to say, but 25 doesn't divide by 4. I know. Guess what? It stays a fraction, or you can convert it to a decimal. So if you do 25 divided by 4 in your calculator, you get 6.25. And so we can draw our number line. And here's 6.25. And to the left of that is going to be 6. And to the right of that is 7. Now, are they equally spaced? No, doesn't matter. I just need a number that's to the left and a number to the right. And so, let's look at our statement. X is greater than or equal to, so I'm going to put a dot at 6.25. And then, is 6 greater than or equal to 6.25? Or is 7 greater than or equal to 6.25? Which one is true? 7 is greater than or equal to 6.25. So my shading will reflect that and shade towards 7. So again, don't think that you're going to get an answer here that doesn't sometimes reduce. We can get those. We can still graph those and put them on the number line. So don't be afraid of what you see there. Okay. So we're going to look at some more examples now, but now these are going to have variables on both sides of the inequality, and we need to solve them from there. So let's look at these next two examples. So in example 5 here, we're given 6x minus 7 is greater than 2x plus 17. And so when we start this problem out, remember that we want to get the variables to one side. So I can move all the x's to the left or move them all to the right. But remember, we've got to deal with operations here. We can't just pick it up and move it. We've got to do something to move it from one side to the other. So either add or subtract it. And so in this case, I'm going to subtract the 2x from both sides, because I always like to move the smaller the coefficients to the other side. And so 2 smaller than 6. And so this cancels. This gives me 4x minus the 7 is greater than 17. My next step, now that my x is on the left, and it's the only x I've got left in this problem, I want to get everything else away. And remember, PEMDAS still applies, right? And so now I'm going to solve this by getting rid of addition or subtraction first. So I'm going to add 7 to both sides. And so 4x is greater than 24. And so our final step, divide both sides by 4. X is greater than 6. We'll draw our number line. Here's 6. To the left is 5. To the right is 7. And so what are we going to put at 6? In this case, we will have an open circle. And what's going to fit? Is 5 greater than 6, or is 7 greater than 6? 7 is greater than 6. That's the statement that wins. And so our shading will go towards 7. Okay? So again, make sure you're judging these based on those values. Let's take a look at example 6. So in example 6, we have 5x minus 12 is less than or equal to 3x minus 4. Again, I like to move the smaller of the variables first from one side to the other. So I will subtract 3x first. That cancels on the right. On the left, we get 2x minus the 12 is less than or equal to the negative 4. My next step, again, worrying about our PEMDAS, right? Working up that order of operations, I'm going to add 12 to both sides. And so we get 2x is less than or equal to 8, because negative 4 plus 12 is 8. And then final step, we need to do what to both sides? Divide by 2 to get the x by itself. And so x is less than or equal to 4. Here's 4 in the middle. 3's to the left. 5's to the right. At 4, I'm going to have a dot because it's equal to. And which statement is true? Is 3 less than or equal to 4? Or is 5 less than or equal to 4? 3 is less than or equal to 4. So that's the way we shade towards the 3. Okay? So again, I don't want you thinking left or right in your head. I want you to test these values and know which one is going to plug in. That's what I want you to do with these problems. So make sure you do that. Okay? So we're going to look at one last thing. We got 2 examples left to do, but these are special situations like we saw with equations. So that's what we're going to check out next. So we have to deal with solutions here because sometimes we're going to get a statement like 0 is less than 5. That is a true statement. And so when we get a true statement, just like we did with equations, if we get a true statement that 4 is equal to 4, now we're dealing with inequality, so it doesn't have to be the same number. It just has to be a true statement. Then the solutions are all real numbers. But if an inequality comes out to a false statement, like 5 greater than 6, then just like with equations, if we get that false statement, there's going to be what? No solution. And again, that statement has to be true or false, including that inequality. So make sure you pay attention to what actually happens. And so let's look at example 7 here. We've got 14x plus 5 is less than 7 times 2x minus 3. We need to distribute this first, here and here. And so when we do that, we're going to get 14x plus 5 on the left still. And this gives us 14x minus 21 on the right. And so we're going to work to solve this. We're going to subtract 14x from both sides. That cancels on the left. It also cancels on the right. And so my next line is going to say that 5 is less than negative 21. And so we don't have any variables left. Again, the only time you judge a statement as true or false is if all the variables have canceled. And so in this case, 5 is less than negative 21. That is a false statement. Because a positive cannot be less than a negative. It's the opposite way around, right? A negative is less than a positive. So this is a false statement, which means there is what? No solution to this problem. There is no value of x that I can substitute into the original inequality and make that statement true. So I can't plug in 0, I can't plug in 100, I can't plug in negative 1,000. They're all going to make the statement false in the end. Okay? And so let's look at the last example and see what happens with it. So in this last example, 2x minus 1 is greater than 6 times 2x minus 1. And so we're going to distribute this to both. And so we're going to get 12x minus 1 is greater than 12x minus 6. And so our next step, get the x's on one side. And so I'm going to subtract 12x from both sides. This cancels. But this also cancels. And so I get negative 1 is greater than negative 6. Again, we see an example here where the variable has completely gone away. And again, this is the only time we judge it as true or false. So is negative 1 greater than negative 6? That's true. And because it's true, that means that the entire number line is a solution, or are solutions, to this inequality. And so the answer is all real numbers. Now, in the previous problem, we didn't graph it, right? Because there's no solution. So what would a graph with no solution look like? Well, we wouldn't shade or circle anything, right? Because there's nothing on the coordinate graph, on the number line, that is going to be a solution. But in this case, everything's a solution. So here's 0 in the middle, negative 1 over here, positive 1 over here, and everything. All real numbers, right? So the entire number line going from left to right. And so that's it for this lesson. Make sure you do your assignment. Your assignment for this lesson is right here. It is 14 questions front and back. It is on Google Classroom, so make sure you watch it, complete it there, or if you'd like the paper copy to do that in class. Either way, this is due today, so make sure you get that turned in before the end of the block. 14 questions, make sure you show your work, graph the problems. I hope you all have a great one, and I'll see y'all next time.